Hey everybody, you joined me here on the ground in Accra, Ghana. We're flying today a Tu-104 with Aeroflot. This plane is interesting, and I haven't really seen any videos about it, at least any English videos about it. We're using Microsoft Flight Simulator 2004, so it's an older sim, but I really want to take some time to explain some of the systems on this plane, give anybody in the future who wants to give this thing a go, who wants to find some English resources, just a tutorial flight, explaining all the systems on the plane, the navigational equipment, performance, characteristics, and basically this flight will cover all of that, at least for this variant, because I might do some other videos about RSBN flight, which is like a Russian VOR, and NAS-1, which is like a Russian inertial navigation system thing, but this is the original variant of the Tu-104. So there's a Tu-104A, there's a Tu-104B. This is just the Tu-104. So we've got an Aeroflot livery from the mid-70s, which for the flight that I'm simulating here, that's not really, it's not very appropriate. It's a little bit too far in the future, but anyways. Our simulator date is June 25th, 2024, so that will become important later on, because we'll be doing celestial navigation. So yeah, we're going to be figuring out how I'm going to explain how this works here, which is the sextant that comes with this plane, as well as some modifications that I've done to the whole astronavigation gauges on this plane. But yeah, I'll be going through all of this, the cockpit, which may look a little bit scary first, but you even got the nice little observer window, almost like a bomb sight, which this plane actually was developed from a bomber, the Tu-16, the Tu-16. Basically, the engines and the wings from the Tu-16 were drafted to a pressurized passenger fuselage, and the Tu-104 was born. This plane has some unforgiving flight characteristics, somewhat notorious for stalling, deep stalls, high altitude stalls, very fast approach speeds because of the swept wings. So that will offer an additional challenge to us. I have a real world weather setup here in FS9. The mod is FSGRW, FS Global Real World Weather. So if anybody wants to know what that mod is, that's the name of it. Here's our flight plan for today. The application is Little Nav Map, which it's very useful for us because we can draw lines and stuff on here. That'll be very helpful for us when we're doing our celestial fixes. So we're going to be taking off from Kataka International in Ghana. We're going to be flying southwest to Ascension Island, and this is a trip of 1,200 nautical miles or 230 kilometers. True course is going to be 226. The current date is June 25th, 2024, and that's going to be very important for our celestial navigation fixes, because we'll need to take that date and look in our nautical almanac for 2024 and use the information there. Time of departure is planned to be 1900 Zulu. It may be after that, maybe a little bit earlier. We're going to try to target 1900 Zulu, but yeah. This here is like a mnemonic that I'm using. So when you want to calculate this, you'll basically subtract the west longitude. If you want to calculate it for an east longitude, you just add it. So that's what, if you're west, you're less, is basically what that is. just to help me remember, because there's a lot of number crunching involved here if you do it by the tables. There's also kind of cheaty ways to do it, but we might do that if it gets a little complicated. Our estimated time en route is just under 3 hours. Our ETA will be at 21:58 Zulu. Actually, 21:58 Zulu. But yeah, I've taken 780 kilometers an hour as a baseline cruise speed. Translated that to 390 knots, and I've just done the pre-calculation, divided 390 by 60, and got 7 knots per minute. So, in case we need to adjust things on the fly with our ETAs and stuff. But yeah, this is the flight plan. This is our assumed position, which is for celestial navigation. I've simplified this by putting them on whole number longitude and latitudes, so you can see they're all zeroed out here. And this is our dead reckoning position, so this is where we estimate to be in 30 minutes after takeoff. We estimate to be at waypoint 1, and this range radius is basically our dead reckoning error. We could be anywhere in this. We're likely to be there's a high probability that we'll be in this range circle because of things like wind can push us off course, but because the distance we've traveled is 10%, it's like a little standard rule. 10% of the distance you travel is about where you'd end up. So it's time for fuel planning. So we know our distance that we're going to travel is going to be 2,300 kilometers. We want to figure out our cruise altitude, so that will require going to this table and determining that. So everything's in Russian, but it's fairly simple. Your y-axis is your altitude in meters, so 11,000 meters, 11,600 meters is our ceiling. On the x-axis is the distance to travel, so 3,700 kilometers is our max range. And basically the red zones are no-go zones. You don't want to be cruising at these altitudes. For this short distance, you do not want to be cruising at 11,000 meters. Same for long distance, you don't want to be cruising below 7,000 meters. Yeah, yellow and blue are slightly less efficient. Green is optimal. So we're going to be cruising at 10,000 meters today. So we just put that in. This is our wind fuel, basically correcting in case of a headwind. Negative numbers are for you add on extra fuel if there's a 150 knot or 150 kilometer an hour headwind. So I checked the weather, and we actually have a slight tailwind. But I'm gonna be conservative and just leave it at nil wind. And our distance, like I said earlier, 2,300. We're gonna be safe and go 2,500. So now we have our loading, which explains like the loading, the weight and balance of the plane. So for center 2 tank, we're only going to load 33% of that. But actually, this is the Tu-104B, so our tank order is not going to line up exactly with this diagram. So you kind of just have to use your judgment for this one, because we're not flying the 104, or we're not flying the 104B. So we'll figure that out. And then this, I'm not sure why this is saying it's max overweight, but I'm not sure why I can't adjust the payload here. But anyways, we can figure out our payload once we're in the simulator. Actually, I've done some testing, and OBS is not able to record the loading page here, so you guys won't be able to see how I loaded it, but I can put it in the description later, a photo or some kind of diagram showing how I loaded the plane up. But yeah, I'm going to basically explain all the systems here. So starting up here, you've got your artificial horizon switch. This is on, this is off. This is our marker beacon light. This is our PSP, which it can be coupled to the RSBN, which we don't have equipped in this plane. So it can be coupled to a few different nav systems, but usually it's RSBN and ILS and SP50 metric landing system, blind landing system, which is essentially it's a kind of Russian version of ILS where it will guide you down to the runway. It'll also allow you to do an orbit around a VOR or an ILS localizer in certain ranges. So I can explain that later, but we may actually end up trying to use this for Ascension. This is your altimeter. It's a little hard to read, but the outer dial is in the hundreds of meters. The inner is in thousands. So this 4 right here is 4,000 meters. This 6 right here is 6,000 meters. 8 is 8,000 meters. 10, 10,000 meters. So the in-between ticks are for 3,000, 5,000, 7,000. So if you want to know your altitude, your base altitude, read the inside knob. Read the inside dial. That confused me for a little bit. Moving down here, this is your vertical speed indicator in meters per second. So 5 meters per second, 10 meters per second. This is our directional gyro, which is, I think it's slaved to the magnetic compass. This, well, actually, you know what? Let's get some power. Let's get some power to this thing first. Might be a little bit easy to explain. So, go into the electrical panel. Flip the battery switch here. All the electrics whirl up. Flip our inverter. This is our standby. This is our primary. And we also, this is off, so we turn on our transformer. Same here. Actually, we don't need to, we can leave this in this position. Actually, no. Yeah, this is off, this is on. The light goes out. This is our, so yeah, let's turn on our artificial horizon. These are the switches for the artificial horizon, so we flip these. Click on the alignment button. This is our airspeed indicator. So 200 kilometers an hour, 300 kilometers an hour, 400 kilometers, 500 kilometers, 600. This is attached to the autopilot, so this will tell us if we're deviating from the autopilot's set course. This is our Mach meter. This is our radio altimeter in meters. 1,200 meters, then all the way down we can switch to 30 meters, and then we can set this to be, not sure why I can't set it actually. Might need to turn some more systems on later, but yeah. This is our overspeed. This is our overspeed light here. That's gonna be kind of important on the 104B because it's a little bit overpowerful. This is our metric SP50 system, so that's coupled to this here, and this is basically used for a blind landing system. When it's in kilometers mode, that basically, it turns it into a rangefinder, so it will tell you when you're 300 kilometers out from the radio beacon that you've tuned. Maybe switch to here, it'll tell you when you're 30 kilometers out. That's basically the scale. flip on this switch and you get into orbit mode. So you can set the orbit. Yeah, basically you can set a 30-kilometer orbit essentially. I don't think you can do a 200-kilometer orbit, but yeah, you can do a 20-kilometer orbit around the airport. And basically this needle you'll basically have to try to center this needle right in the middle to stay on the orbit. Let's see what else here. This is just your hydraulic pressure. This is your secondary vertical speed indicator. This is your flaps indicator. It's your outside air temperature. And I'm not sure what this is. This is your cockpit air temperature. So it's pretty good right now. Got your RMI needle. Actually, no. This is your RMI. This points to your ADF1 and ADF2. This is your revolutions per minute. So it can go up to 5,000 RPM for the turbine engine. This is your EGT. This here is your panel lights, and actually they're duplicated here as well, and they're also duplicated here. So it's getting dark now. Let's turn these on. Yeah, I think that's it for the captain's panel. Okay, so now this is the middle panel. You can use these to switch between them pretty simply. You got your clock here, which is in local time. You got your hydraulic pressures, brake hydraulic pressure. You got your low fuel pressure warning. This is your 30 minutes left of fuel. You got your fuel flow meters here in kilograms. You have for each engine now, there's a fuel pressure, oil temperature, and oil pressure combined gauge. You also have your turbo starter exhaust gas temperature gauge and your turbo starter RPM gauge, and this is used for just starting the engines, whether that's on the ground. Yeah, and you basically got these duplicated on this side now. Also, you got your sextant here, so this is the main thing we're going to be using for navigation. You can see right now it's twilight. It's astronomical twilight, so it's kind of blue right now, but yeah, pretty much everything here is duplicated on the captain's side except for this, which is our this is supposed to be our astro compass pointer, but I haven't been able to figure out how this works. At least there's, in the navigation section, you'll see that it doesn't really seem to connect to it, but we have alternatives to this. Everything here is duplicated, except there's actually more gauges here for fuel. So this tells you the fuel levels. This is the total fuel level. This is for each fuel group. So actually we want to actually turn on the fuel gauges. So these two switches are for turning on the fuel gauges. So we'll flip these and we'll see the fuel level start rising. And this should basically just top out around, I think 12,000 kilograms, because this is actually doubled. So 12 times 2 is 24 tons of fuel, and we do have 24 tons of fuel on board, 24,000 kilograms, which is what we calculated earlier. And yeah, now we can go through each fuel group. We use fuel group 1 first, then fuel group 2, then fuel group 3. This is our cabin altitude difference. This is our cabin temperature here, cabin flow rate. Basically, these are all the pressurization and cabin climate control switches. This turns on your pressurization. You do this to increase pressure on the left one and on the right one. They're not working right now because we haven't turned on all the systems, but that's basically how it works. These two control your temperature, hot and cold. Moving down to the electrical panel again. I explained this section already. This is your voltmeters for each generator. This is you can adjust the voltage regulator, so it's a voltage regulator for each generator. You got 2 generators per engine. These are your generator switches, so once engine 1 is on, switch these. Engine 2, switch 3 and 4. Now, this is all of our actual onboard equipment here. So we got the 2 ADFs. You got, I think this is your COM1, COM2, yep. This is your flaps, your radio altimeter, and SP50. This is the NI50 actually. But yeah, everything's been switched on here. Let's leave these off for now. Okay, so next section here. The side panel. Side panel, this is your parachute, so you can press this to turn on the parachute because this plane does not have reverse thrust. Or you can press slash, which is the default spoiler key in FS9. This is your throttle quadrant, so if you want to stop the engine actually, you press right click here on this click spot. This is on, so I'm moving my throttle. But if I click here, I can just cut fuel to the engine, just like that. This is your elevator trim. This is your aileron trim, rudder trim here. This is your landing lights. So this is to extend them. The neutral position is lights off. So we wait 10 seconds. Now we can extend it. So all top, this is our landing lights fully extended. And this is our taxi lights. So down is taxi lights, middle is no lights, up is landing lights. I'm just gonna retract them now. I'm not sure what these are. They don't seem to really do anything here. I believe, yeah, I'm not exactly sure what these do, but I'm gonna turn these on anyways. These are our panel lights, like I said earlier. These are the engine start controls. So turn this one on, then you turn this for the turbo starter, then you turn it off, and then you flick this one to turn on the actual engine itself after the turbo starter has spun up and then spun down. I can get into the starting process later. This is our fuel panel switch here. This is our fuel cutoffs for engine 1 and 2, automatic fuel management system, so we don't really have to do any fuel management ourselves between 1 and 2. This is our primary fuel pump switch. This is our navigation lights, A&O. This is steady, no navigation lights, and flashing. So we use flashing for engine startup as a beacon, because there's no beacon light here. This is our anti-ice. These are our alternator switches, and this is our pitot heat. So alternator switches, I think they're doubled with the ones in the electrics panel, but yeah. This is our fuel control switch. It's already open. Anti-fire. This is our crossfeed. We don't really use this. And we clip on this because this light tells us which group that we're using, so we're using group 1. One thing to note actually is that in this plane, if you don't have left aux fuel, then the plane won't start. It will start if you use Control E, which is like the standard, like skip all the cold start stuff button, but basically you have to have some fuel in left aux, because that's just how Microsoft Flight Simulator calculates. It starts draining from left aux first. So you have to have some fuel in there, and then you can remove it later on, but the fuel group switches are here. That's the fuel system. This is our autopilot. I'll explain that a little bit later. This is our NL10, which is like a flight calculator. It's similar to the E6B, calculating things like the distance to go, true airspeed, wind correction angle, stuff like that. I don't really know how this works, to be honest. I haven't really used this before, but I don't know, maybe we'll get a chance to do that one day. This is the ground mapping radar, so turn it on, change the range of the radar, see that we see some bodies of water north of us. And actually we can use this for pinpointing how far something is. So we can change the azimuth, and then we can change the range. So this body of water is about 90 kilometers away from us on a 2.8 true course. So that can be useful. Here's the navigator section. We have here basically like a navigator notebook. Tells us the current winds from magnetic course and wind speed. This is our ADF radio frequencies that we can tune down here, and this is just your standard kind of coffee grinder style ADF radios. You can also tune in the Morse. Actually, this turns on the lights, and I believe this is for tuning into the frequency, so you can listen to the Morse code basically and determine, like, guarantee that frequency is what you're listening to. This right here is the what I was talking about earlier, the SP50 metric system. Essentially, this is your calibration for your orbit, calibration for your range correction from 0 to 30 kilometers, and this is your correction for 30 to 300 kilometers. So basically these touch the needle here, and they calibrate them. But in this simulation here, on this plane, in this panel, you don't actually need to do any of these corrections. There's another one in the 104B that I've modified that you do have to adjust these, because they're initialized to random values. But yeah, essentially this determines the radius of the orbit. So 9 kilometer orbit, 11, 19 kilometer orbit. And this is the navigation radio, so you can tune in ILS here as well, or even a VOR. This green or this yellow flashing means that a signal has been detected. So we don't actually want that. There we go. Okay, so this tells us our true airspeed. This is like a true airspeed indicator. This is our outside air temperature. This is our secondary altimeter, secondary clock. This is non-op. This is non-op as well. Altimeter here, or sorry, speedometer, not speedometer, airspeed indicator in kilometers an hour here. This is our magnetic compass, and before every flight you need to press this button here. This is the fast align switch, so either you wait like 10 minutes and this needle eventually turns around all the way and points to your actual aircraft course, or you just hold this button and then this needle will spin around much quicker and hit your actual course. So right now our magnetic course is 347. Okay, this is our NI5. Essentially, it's like a very basic version of the NAS-1 system. So people who flew the Tu-154, the Tu-134 might be familiar with the system called NAS-1, where basically those planes have a radar which checks the wind speed and wind direction constantly, and basically makes adjustments to the course so that your plane stays on a certain track. So it's kind of like an IN. It's not like an INS, but it's kind of like it. You can kind of follow waypoints with it. But anyways, this is a very simple version where there's no radar that detects the wind speed. You just kind of have to feed in your wind information here. We're not probably going to use this at all during our flight, but the outer layers for your plane course enter for the wind direction, then the wind speed here in the middle. This is what I was talking about with the astro compass. This is your Astro DAC-DB Astro Compass. We can make it a little bit bigger here. You're supposed to set your latitude here, and then you're supposed to set your longitude here. But I haven't been able to figure out how this works because there's actually like a little cheat button here. You press in the middle here, it's supposed to automatically do it. But I tried setting this and it doesn't stop this plane from moving. So yeah. This is also, you're basically supposed to set your Greenwich hour angle for the body that you're shooting, like the celestial body, which can be found in this notebook, which we're going to get to. This is our navigational notepad. It's basically a kind of automatic calculator, and it gives us a bunch of useful information about certain celestial bodies, their Greenwich hour angle, right ascension, azimuth, declination, all that sort of stuff for celestial navigation. We also have some correction tables, some helpful formulas. We also have a whole section of stuff for the NL10 flight computer that I was talking about earlier. I haven't really looked at this, but anyways, this is all in English, you might have noticed, but that's because I've actually modified this. I've Google translated everything here, and I've modified the gauge itself, because before this was all in Russian, and it was kind of hard to understand. But basically, I've also added I've added more stars here. So originally there's 28, 27 navigational stars that were provided by this mod, but I've added all 58 navigational stars. So anything you see in like Pub 249, or if you want to shoot like, I don't know, yeah, like Merfolk here, this was not included in the original mod. So you can shoot Merfolk. Right now you can't because the height is -21, but if you wanted to, you could. All the other stars do not show up here yet because I haven't had enough time to populate this, but the sextant itself does have the capability of shooting more stars than what's on this notepad. That's just the important thing to keep in mind. But yeah, we got our date here, we got our current assumed longitude and latitude, time of the fix that we're planning to take, our right ascension, our SHA, our LHA of the first point of Aries, which is 186 right now at this exact time and latitude. Yeah, I'll go more into detail about this when we get into flight and we're actually using this thing. So we're at this Pub 249 Volume 2, and I've actually done the pre-computation form for the first shot at 1930. I estimate we're going to be at 33,000 feet, but we're probably going to be closer to 30,000. True heading track is going to be 226. We don't know the winds. Ground speed, I'm just going to put 425 knots, which I think we're going to be a little bit slower than that because we're actually this here. We'll just leave it at that. But yeah, basically put in the longitude and latitude for our fix. This is the current longitude and latitude. Follow the instructions here in the astronav. Basically we're going to first get the LHA of Aries at the time that we are doing our fix shot. The GHA is in the 2024 Nautical Almanac. We apply the 30-minute correction, which is what this is. Then we get this GHA. Then we subtract west longitude. So we were subtracting -2 west, but because we need to make this a whole number LHA, we subtract -2, 55.6 minutes, and that gives us 204 LHA for this time. Assume latitude stays the same. Then I go into Pub 249 Volume 1. latitude 3 north, go to 204. I find the 3 stars that we're going to shoot. We're going to shoot Alpheca, Rigel, Regulus, and I entered the azimuth, which is the ZN, and the height, which is HC, that calculated height, and I've entered that into the plot already. So this comes from 249, and I'm doing the shots 1 minute spaced out. So 1 minute before the actual shot, 2 minutes before the actual shot, and I've applied those corrections here with the X time. So these calculations here, this is the azimuth minus the track, so 48 minus 226, that's going to be a negative number, so we plus 360, and we get 182. This is useful for us because when we shoot the star in our sextant on the plane, we're going to be using this azimuth, because the sextant is actually, it's modeled in the simulator to be oriented to our plane. This is the motion of body. This is the motion of the star. 1 minute before the fixed shot time, and then we times that by 2. This is the motion of observer, which is based on our ground speed. So we're going about 400 knots. So this is what this calculation is, and then you add these together. Then based on the sign here, we turn this into a positive, and then we can add it. Coriolis there's not really much of a factor here because we're close to the equator. And then yeah, we get our adjusted HC, and then this is an old star shot. I'm gonna remove this. And also I put this here. This is just the ZN here plus 180, and this is just so that we can plot it very easily. If in case our intercept is away. If our intercept is away, then we use the plus 180, the reciprocal basically. So we plot like 8 nautical miles away from the star, so that's where this number is useful. So that's just there as a quick guide. So we're going to time our startup and our departure pretty carefully here. Right now the time is 1850. We want to depart at 1900 GMT so that we can get close to our dead reckoning position at 1930. So let's get this thing started up. Let's turn on all the fuel pumps. Make the beacon flashing. Let's go into our side panel. Let's turn on the turbo starter. So that's what this is, the master start switch, and this is our turbo starter. We're going to watch that go up and then go down. Let's do the same for the other side too. Alright, 24 kilograms of fuel. Turbo starter to stop. Let's turn them off. Start up the engines. Let's turn on the taxi lights. I'm just gonna turn on my weather.
Short of runway 3, taxiway. Contact tower 118.6. Taxi 2 and hold short runway.
Call for pushback. This taxi is telling us to take off in the opposite direction from runway 21, but we're going to take off from runway 21 because the wind, I haven't gotten the weather in, so I think the agency doesn't know what the right runway use is. It's going to flaps now.
Закрылки выпускаются синхронно.
So flaps 20, we're going to take off 280 kilometers.
Режим взлетный, рут держать. Взлетаем, рубеж 200 полсотни.
3000 RPM.
Взлет прекращаем.
Says 230 degrees at 8 knots, so we should be taking off from 21. So we're just going to go to ADC. Just make sure everything's set up a pressurization before. Also, haven't turned on the generators yet, so there's a few more electrical things I haven't done yet. Pidometer. This is aligned. We'll do that to the other way. Looks like there's thunderstorms. Let's align this one too. So our pilot. Before we take off, let's do some. Let's make sure our generators are running properly. So let's go to generator 4. Make sure it's at 27 volt. Use the voltage regulator. So this is an option, but it's for more realism. Let's we want to take off at 6:50, 7 p.m. local time. What do we need to do? It's all good. I think this is close enough to the time that we can take off in about 30 seconds. 6:58 right now. Just do one last check of everything. Oh yeah, get our pressurization up. So we want to take off 280 kilometers, 10 meters above the ground. We'll remove our gear, we'll retract our gear. Then before 400 kilometers we will retract all of our flaps. Flaps 10 at 350, flaps 0 at 400. Then we'll climb at 600 indicated, going up to 600 true airspeed, which is our small needle there.
Режим взлетный рут держать. Взлетаем рубеж
Eventually
200.
climb at 800 kilometers true airspeed, so let's go. Oh, I haven't even asked for permission to take off yet.
Двигатель на взлетном, параметры нормы. Рут держал.
Doesn't matter. Let's just take off. Oh, there we go.
Скорость растет.
Rotate.
Безопасная. 6 убрать.
Positive rate.
Скорость мала.
Gear up.
Фары выключить, убрать. 60.
First stage of flaps. We're going to turn to 229 now. We're just going to turn straight to 229.
120. 120. Шасси убрано, створки закрыты.
Alright, we're going to reduce our speed.
Сигнализация убрана. Режим номинальный.
Alright, let's turn the autopilot on. Make sure this is going
Скорость велика.
sort of lower.
250 метров.
Make sure we don't fall to the ground here. This is our pitch control. Let's go to a little bit more to the right. We're at 227 right now. Let's also reduce our RPMs just a little bit. Just a touch. Okay, we're at 229 now, centered out. 1,600 feet per minute. 8 meters per second. So radio altimeter is telling us we're just past the 700 meters. Got a bit of turbulence here. Okay, we need to be going to the right a little bit more. Takeoff was at 7:02, 7 p.m. exactly. Take off the landing lights. Yeah, we're hitting some pretty bad turbulence right now. actually have this autopilot enabled? Yeah, we do. It's just turbulence is not great. Let's lower our angle of attack just a little bit. We're getting a little bit too much here. Want to keep 600 kilometers indicated. Now the nice thing about doing that pre-computation form is we've got pretty much our work cut out for us. We don't really need to do much there. We just need to take the sextant shots at 1928, 1929 to 1930. Let's actually reduce the sound a little bit. It's getting pretty loud. It's kind of loud. Alright, there we go. My mic is kind of low, so let's get a little bit of power up here. It says the maximum RPM is 4,400, but I find that 4,500 is helps it climb a little bit better, builds up some more airspeed. Reduce the angle of attack a little bit. There, looks good. Still tracking 229. Let's check our master. So it says we're going 228, but I think it's fine. Take a look at our climb performance. So we're at 2,600 meters, so we should be 600 indicated, 650 true airspeed, which is just about where we are at here. Tracking a little bit to the left here. We need to go to the right. I'm gonna skip past in about 10 to 20 minutes or so to our first star shot, and don't really need to see all this management of speed and stuff. The workload is a little higher than a normal jetliner, but it's not too crazy. So we're coming up on 1928, which is going to be the time of our first shot, FHAW. We're nearly at our cruising altitude of 10,000 meters, 10 kilometers. We're maintaining 800 kilometers an hour true airspeed, which is the skinny needle here, 4,400 RPM. We are probably going to keep climbing through this shot, which is maybe not ideal, but I think it's going to be alright. We can always descend if we need to. So I've already set up the sextant here with the 182 figure that we had here for FHAW. Our height is 53 degrees 2.8 minutes. So I've got it kind of approximated, and we can already see our star here. The controls here, this is to control your azimuth, the A right here. This is to control your height. This is the course adjustment, slightly finer. And then here we have minute adjustment. Minute adjustment is course, slightly finer. But anyways, we're getting very close to our shot, so we're going to turn on brighten up the little display here. We're going to change the size to be small. This is our zoom levels, so we can go zoom in quite a bit here. So we're going to zoom in, we're going to try to get this as close as possible. Okay, so our shot was already taken. we're going to say it was 53.17. So let's go back here and fill that out. We'll be very quick with this, 53.17, because we're going to go 171 now. We need to shoot Rigel now, so we're going to be very quick with this. So 171, zoom out just to make sure we're shooting the right star here. 24. So we need to be 24. We're zoomed all the way out here. I think it's not this one. I think it might be this one here. So we're gonna need to go down. That doesn't seem right, to be honest to me. I don't think this is right. We're gonna need to zoom out here. Oh shit, okay, I fucked up. It was 305. I need to be at 305. So we messed up a little bit here. It's probably this one right here. So this is just what happens when you mess up. So let's just say it was 24.24.4. 24. And we need to get to this shot, 57, very quickly. 57. And that's gonna be 38, so it's probably gonna be this one right here. Yeah, so it's already counted, so it's probably 37.54. So, yeah. Alright, so we've done our shot. Let's make sure we are almost at 10,000 feet, so let's increase our climb speed so we can get to 10,000. Let's do our math here, so it's very simple now. If the HO is greater than HC, which it is, we plot a 2 intercept, so we use the regular ZN. We don't use this one. Same with this one. This one's below. Okay, so this one is lower. The HO is lower than HC, so we go away. So 46 minus 24 is 22. Then for here, same thing. 6, 7. That's 13. 37 is lower, but then this one is, let's just round this up to 3, so that's 14. So let's do that. Let's plot that. So let's go to a little map here. 48.2. We're doing true courses. 48 true. And we'll do 14. So just there. And then we'll do 22 away, so that's 351. 351. That was what, 22? 351 and then 22. It's pretty far out, so there we go. And then we're gonna increase this a little bit more. Okay, we are actually at the right speed, so let's reduce to 4100 RPM. Make sure we're not descending here. Okay, 13 nautical miles, 103. 13 nautical miles. Okay, so now we can plot our thing. So 48 true, 48 minus 180, or sorry, 48 minus 90 plus 360, because we want to get the perpendicular line of position going to the left here and the right here. So let's plot from here, 318. Perfect. Then we'll do 48 plus 90, that should be 138. 38. And then for here, we will do 351 plus 90 minus 360, 81. Let's see, 81, let's make this a big one here. Okay, and then 103 minus 90 is going to be, shoot, 13. So we are here, basically. We are somewhere in the middle here. So this is our derived position. We're going to put that in the middle, and now we're going to, so we're pretty much on time, pretty much. So let's plot our course to the next waypoint. So it's going to be 228, so we need to be 228. So we are pretty much on course here. Okay, we're on course, but we are not going in the right direction here. Alright, 228, stop to count there's. Let's align the gyros. We're pretty much on course, so we don't really make too many adjustments. Now we're cruising at 10,000 meters. Let's actually reduce the speed of just a little bit, because we don't want to be going too fast. Let's go to 3,700 RPM. I want to be targeting 800 in the cruise, so you can see our Mach meter is, we're at 0.75 right now. Maybe you want to be 0.73. Alright, so I've done some calculations here. We're going a little bit faster than I wanted to, but we're going to adjust our dead reckoning waypoint. I've done some calculations. It shouldn't be 210 nautical miles, it should be about 280. So we're going to do that actually. We're going to adjust this. We're going to adjust our dead reckoning position. 288. This is about it here. We're still going to use this AP. Can remove the range ring. And let's just check our course here to ensure that we're at 2828. Yes, we are. Okay, 228. Everything looking okay. Let's not descend. I don't know why we're descending here. Let's just increase a little bit more power. Alright, so instead of, this is actually our real position after we took the shot, because we estimated this about 6 minutes after, so I've interpolated that here. But our next waypoint is here, and we're at a range ring here. Our dead reckoning position, so we need to actually be, yeah, we're good. We're on course here. Alright, let's do our calculations here. So this will be at 8 p.m., so we need to do this pretty sharp. Actually, what I want to do instead is I'm going to rely on this here, this notepad, just to give an idea. Instead of doing all the calculations with the nautical almanac and stuff, we're going to instead use this. So we'll put in our AP, which is 00005 west. (5 degrees west). Perfect. Okay, and then the time will be Well, it will be 1930, so it'll be 20. Alright, let's see what stars we can shoot now. Let's edit this here. So we're gonna do fixed time 20Z, true heading 226 still. It's just a little bit less actually. Our true heading is 228, which is 228 is still 226 true heading, so let's keep that. Ground speed is now 850 kilometers an hour, 2 knots. So ground speed is 450 now. 450, latitude is 0, longitude is 5 west. We don't need to do any of this Aries calculation. We're just going to pick 3 stars here. Everything is good. Just need to increase the angle of attack because for some reason we're descending. Anyways, let's I'm gonna shoot a crux here, Southern Cross. So let's put that in. Actually, we need to check our. So our heading is here. At this position, we want to shoot a star that's going to be about. There's 360 degrees. We want to shoot 3 stars, so we divide 360 by 3, so that's 120. So we want to shoot stars that are about 120 degrees apart. So let's do 190, 191 true. That's a crux. So we want to shoot one that's like about here, and we want to shoot one that's about. And then we want to shoot one that's about here. So we're looking for 80. This one is a good one, but it's too far below the horizon. We don't want to shoot that one. 13. Nope. 81. Doesn't need to be perfect. Okay, so right now for this one, Regulus, we can shoot Regulus again here. 284 is good enough. .284. .3209. 3209. The crux was 2436. Let's see, so now we're looking for like an 80 true. So nothing really stands out to me, unfortunately. Maybe Antares. 29. We might just have to go with Antares here. Yeah. So we got one in front of us, we got 2 on the side. So we're going to go for Antares. And Antares is 44. 38. And we're not going to do the complicated motion of body calculations. Instead, what we're going to do is we're going to take our true airspeed and we're going to turn that into, because we know that our shot time is going to be 1958, 1959, 1920. So I'm just going to subtract 2 from here. So in 2 minutes, so 2 times, if we go 830 divided by 60, so 830 kilometers an hour, that's 13 kilometers a minute. So we're going to be traveling 27 kilometers, 27.6 kilometers to nautical miles. That's going to be 24 nautical miles. So we're going to do 24 nautical miles in this direction. So what is the reciprocal of 226? 226 minus 180, 46. So we'll do 46, 24. And that's going to be our minus 2. And then we're going to put one in between. That's just going to be our AP minus 1. That's going to be our 1959 shot. Okay, so that's good. Alright, let's... Okay, we need to move to the left a little bit. We are getting off course. Speed is good. Let's lower just a little bit here. Alright. We've gone a little bit too far. Okay, there we go. 228. Let's check the time. Okay, we got about 12 minutes. We have 12 minutes to do this. Calculations here. So, ZN 191 minus 226 minus 226 plus 360, 325. 284 minus 226. 284 minus 226, 58. And then we have 129. That's 360, 236, 263. Okay, and then, yeah. So we don't need to adjust anything here. We should adjust for refraction. Let's take a look at our refraction table. So this is also the pub for 249, but we're going to use this one because we can. We are at 10,000 meters. The first one's 24, so we'll get a refraction of 1. This was 32, so we have a fraction of 0. 44, same thing, fraction of 0. Okay, so this is just 24, 37. Coriolis effect, I don't think it's going to affect us because we are at 0 pretty much. Alright. Let's adjust our... Let's get ready to shoot the first star. .2436. This is probably it right here. I don't think this is it. I think this is our target here. We may be quite far off of it, but we still got about 9 minutes or so. That's just enough time to plot out the, get the reciprocals of these. Coriolis, I'm not even gonna calculate that. I don't think it's necessary. None of this is relevant. Okay, this is all, wait a minute. Yeah. This is all accounted for. Oh yeah, actually, we do need to be careful here because this is the shot time here, this is the values that we're getting, so it actually might be a little bit different. So what we really should do is we should crux 2441 actually. So this is 2441, 2442 for Regulus. $32.23. Wow, that's actually a big difference. $32.23. 23. Okay. And for Antares, it's all the same. Put it for 38. Okay. Okay, we are still getting off course here. 32. Let's get back on course through height. We can descend a little bit. Reduce power just a little bit. We have about 6 minutes. Am I joining us back at 7:58? Alright, we are at 57 right now. We're gonna take our shot soon. This is pretty far from the observed or calculated height. 2347 is very far from 2442, so we may have made a mistake here. I'm hoping not, but we'll see. Almost at. And once we take the shot, we need to quickly pivot to the next one, which is at 58 azimuth. Alright, we are going to be at 2350, so 2350. So that's going to be away from this. That's going to be 52. Alright, let's quickly go to 58 azimuth. Let's see. That's going to be at 32, so it's probably this one right here. Alright, 33. 32.59. Basically 32.56. 32.56. Alright, pivot to the next one. 260. 263. Zoom out so we can get a shot. 44 is probably this one up here. 43.49 probably. 43.50. Let's call it 43.50. 43.50. Okay, so these are pretty far off. So let's calculate these right now. We're gonna go all here because away. Okay, this is 56. This is 33. And this one is 38. It's 48. This is pretty far. We might be pretty far off here. So let's do 309. 309. 309. Oh wait, actually, we may not be. 309 and then 48. 309, 48. Because of how far our AP is, we actually may not be too bad. So 33 is going to be 284. And then 52 nautical miles, 11 degrees. There we go. Alright, let's do this. Let's do this quick and dirty here. Not even gonna do the normal. Actually, we are gonna do the normal thing. 11 minus 90 plus 360. 281. Okay. 309. 309 plus 90 minus 360. 39. And then here. 284 plus 90 plus 360, 14. Okay, so we got our AP right here. It's a derived position. Actually, okay, but the problem is so now we've traveled about 2 minutes, so 2 times this, so that's going to be 2 times this. I think that was kilometers to nautical miles, so we're just trying to so 15 kilometers this way, so let's do 15 nautical miles in this direction, so it's about here. So we are right here, so let's actually, where we need to be is, we're actually going a little bit slower, so we need to be, we're hitting some headwinds most likely, so we need to be at 229 to 30, so let's go to 30, we're at 31 right now. I think the calculation here is we're still on the right side of the thing, so we're getting winds from, we're most likely getting winds from this direction here. Let me actually just check. Yeah, we're getting winds from, no, actually we are getting, we're actually getting a tailwind, which is interesting. Oh no, we're not. Okay, anyways, I'm actually curious. No, we do have a tailwind. We have a very small tailwind. We just need to be more on the right here. We're a little bit too much to the compensating a little bit too much here. 237, we need to go 231 maybe. may need to increase our speed just a little bit. We're also climbing for some reason. I don't want to climb. Not sure why we're climbing. We've climbed about 300 meters, which is not what we want. So we're slowing down just a little bit too much. I don't want to be that much descent rate. Alright. So we are currently 197 nautical miles. 97. 364 kilometers. So if we divide our current airspeed, it's gonna take us 26 minutes, which that lines up. That's about here. So let's start doing our calculations here. So let's do a proper motion body shot. So latitude is going to be AP3 2 south 8 west. Ground speed, everything. Change this to 230. Gonna ignore all this stuff. Okay, so we're gonna check Aries. So let's go to our nautical almanac. Let's go to June 25th. Just make sure we're June 25th. Looking for Tuesday. We are at 20. Let's take that. And then we're looking at our correction. I think it was 7. So we're 30 minutes correction. I think it was 7.13 or something like that. 7.31. There we go. 7.31. So let's calculate this. GHA is going to be 7858, and then it's going to be 221.58. 221.58. Yeah, 221.58. So longitude is still west, so we're going to subtract our west longitude. We're going to turn our west longitude 58 now, 58 minutes, to get, what is this, 213. Assume latitude is south. So, we've got to adjust our AP here a little bit here. Adjust our AP, so 58 west, 58 minutes. Okay, here we are now. Okay, so let's go to our pub 1. Let's go to 3. Let's go to 3 south. 2 south, actually. So 2 south, and then our LHA is 213. So we're going to be shooting Vega, Rigel, and Regulus. Vega is 213, okay. 1651.48. 1651. This is going to be at 2028, 2029, 2030. Rigel 3050 176. 76, 30, 50, 30, 50. And then Regulus is at 28, 11, 285. 285, 28, 11, 28, 11. Let's check our plane. Okay, we're still climbing for some stupid reason. I'm just gonna make us descend. I think it's our engine RPM is just shot up. Yeah, let's descend. Still got a lot of time left. Still got about 18, 17 minutes before we hit the shooting of the star. So 48 minus 226, 48 minus 226 plus 360. 276 minus 226 plus 360. Let's do our motion of body calculations as well. So we're going to do motion of body. Actually, let's do refraction. Height above sea level, about 30,000 feet. 16. It's just a refraction of 1. Oh, I've actually been adding it to the sextant altitude, just be actually subtracting. Let's see. 30. So it should be 2. No, it should still be 1. And then Regulus is 44. Or 28, which is still 1. It's still in that range. Okay, let's do motion of body now. Oh yeah, Coriolis correction. Latitude is still between here and here. I don't think we need to do any Coriolis correction yet. Let's go to motion of body, which is I'm trying to remember where it is. Yeah, here it is. Correction for 4 minutes at a time, correction for 1 minute at a time. Where's correction for 1 minute at a time? Yeah, here it is. 450 knots. Let me just check my... Yeah, we are going a little bit too hard here. I don't know why we were at 234 or 237. We were at 237. That's not good. Let's do 450. Relative ZN is our relative ZN is the... Sorry, I think relative ZN is our this one right here. So 182. 182. It's 180 right here. Okay, so 182 and 180. So we're looking at minus 7.5, but I'm gonna go here minus 7.5. We actually need to add it. So plus 7.5. This is the motion of a observer. 7.5, and then for here, 310. 310 here. Plus 48. Plus minus 48. So this is x2, x1, x0. So we don't even need to do anything here. Just ignore this. So let's do motion of body for here. Correction of 1 minute change. True ZN 48. 48 here. And our latitude is going to be pretty low. It's going to be 11.1. 11.1 is positive. So we subtract 11.1. Let's just make sure we're heading in the right direction. Okay, so 176. 176. That's going to be plus 1 minus so this is going to be minus then this is going to be total motion correction is wait a minute, what? Okay, I've actually been doing it wrong. It's multiplying negative and positive. So it's still negative 7.2. And then this one is going to be minus 5.5. So the total is going to be minus 8.2 here because it's plus this one. Minus 6.8. Then minus 1. So minus 8.2 minus 6.8 minus 1. So 51 minus 8.2. 42.8. $50 minus 6.8. 43.2. Let's get our sextant prepared. I know we still have like 10 minutes, but yeah. Okay, so this is just gonna be 28:10. Okay, So we've got everything set up now. So do 48. 28, 176, 180. I think this is gonna be like 356, yeah. 285 minus 180, 105. Okay. So we got everything set up now. Alright. Now all there is to do is wait. Yep, we're gonna start shooting this star now. We're at 27. We're gonna start shooting, this is Vega? Yeah, this is Vega. Come on. I think this is all just the motion of the airplane right now. It's doing this. So it's not super easy, but I'm just gonna get a nice round number here. I'm gonna say 17, 18 is probably what we're gonna put in there. Yeah, let's put 17, 18. 17, 18, 17, 18. Alright, now we need to quickly put it to 310. Because we need to be at 30 now. And I think this is it right here. Yeah, 30, 45? Let's say 46. Okay. 59, that was actually, that ZN was actually 314, so we'll make note of that. Okay. 59. It's probably this one right here. $27.25. 25. Alright, so there's a big difference here. So let's do 60 minus 42.8. 17 plus 18. 35.2. So this is going to 35.2. This is also going to, so this is like 2.8. And then this one is going from, so this is 20, 35, 45 nautical miles away. Okay, let's do that one first. So 105. 105, 35 nautical miles away. Oh, shoot. Actually, it's 45. Wow. Oh, it's 105. Okay. And then this one is 2.8 at 176. 176. 76. It's 2.8. So right here. And then 48 at 35. 48. 48 at 35. Okay, let's do that now. So 105 minus 90 is going to be 15. Let's do 15. Let's make sure our plate is nice and level here. I'm going to reduce the RPM just a little bit. So 48. 90 is 138. And then here it's 176 minus 90, 86. So here. Okay, let's see. That is a very, very small window where I could be. I don't actually know if this is where I am. But let's just say that that is the case. And then I need to be going this way. So it says 233 now. Okay, so we need to be going a little bit off to the right here. The thing is, I'm actually getting closer to the line, so it is kind of working. It is kind of working. So I don't want to go too far off to the right. I'll just go 232, I think. This is good. It's a decent number. Right. Nice. Now we're actually going 850 true. So we're going a little bit faster. Um, 850, 14.6, so 30 minutes, kilometers to nautical miles, 229, so we actually might be needing to adjust our position again here. Somewhere around there, that's fine. Alright, that's pretty good, okay. Let's actually, we should be going a little bit further to the right here, to 233. Yeah, everything's going pretty well right now. I haven't had to make too many major course corrections or anything like that. And we are now, so our next plot is going to be at 21.0. Let's see, 21.0. It's going to be at 4 south here, and then 11 west. Still looking at Aries. Let's go to our nautical almanac. No corrections here. Just gonna go back. $25. 21. So this is our new GHA. No corrections need to be applied. Let's do minus 11, and then we'll do 29.3, and that's going to be 18 to 18. Assumed latitude is going to be 4 south. We're going to do 29.3. So we're going to adjust our AP. $11:29, and then to get the seconds, we're going to do 60 times 0.3, 18 seconds. 18 seconds. So there's our new AP. We're going to look at our LHA for 4 south. Just make sure the plane is doing what we want it to. Yep. This is 218. 218. So we're still shooting Vega, Rigel, and Regulus. It's just 1910 this time. Also, I haven't changed these, but let's do 2058, 2059, 21 0. 46 this time. And 179. And 285. So that hasn't changed. 2251. $33.04. Now the motion of body, I don't think this is going to change much, but we're going to do the calculations anyways. This is 180. I think this is like 307. Let's just make 100% sure. No, I'm done. And this stays the same. Let's check at the motion of body. So let's check the refraction too. It's 19, 33, 22. There's the refraction. No, I think it's all the way down here. or all the way up here. Alright, I'm misremembering where this is. Let's make sure we are everything's good here. Okay. Oh, there's a refraction. Okay. Okay, let's just do the motion of observer, motion of body corrections first. So 450 relative Zn is 180. Let's see. So it's still minus 7.5. That hasn't changed. It's minus plus motion of a body. True Zn. Zn is 46. So it's here now. Latitude. Latitude is now 4 south. So it's 10.8 now. 10.8. Minus 10.8. 10.8. 46. Yeah. Minus 10.8. And then motion of body for this one is 179. So it should be between this and this. That's 0.3. Minus 0.3. Or 0.2. Let's make that even. Motion of observer. 450 ground speed. Relative Zn is 313. It's going to be 5.1. It's a positive. So we subtract 5.1. So this is minus 5.3. 5.3. This is 3.3 minus 3.3. That's going to be minus 6.6. This is going to be, yep, okay. Let's do refraction now. So 19. Fraction is still 1. 33. Fraction is still 1. 22. Yep, it's all 1. Okay. So this is now minus 7.6. This is minus 6.3. 7.6. 6.3. So this is calculated as 10 minus 7.6, 2.4, 19, 2.4, 4 minus 6.3, 4 minus 6.3, that's going to be minus 2 or 3, 60 minus 2.3, 57.7, 7.7, that's going to be 32, 57.7. And then 2250. Okay, we got everything. Let's do 46 plus 180. That's literally 359. 285, it's all the same, okay. Let's check our fuel actually. Yeah, turn on group 2 now. Alright, so we got 12 minutes until we need to start shooting stars, but let's get this set up ahead of time. This is probably what the star we're shooting here. Alright, I'll join you guys back when we'll get closer to the time. So, 56 minutes, about to be 57, we're going to take our shot soon. I've already lined up the star here, so we're getting ready to take our shot very soon. Make sure we're still on the right course. Our course has changed to 234 magnetic, so that's fine. That's what little nav map tells us. I've also slowed down just a little bit here to 830 kilometers. Alright, let's get ready here. Alright. Alright, we are at 1856, that's our shot. 1856. Quickly pivot over to this looks pretty close to our HC, so we're gonna take the shot at this star soon. I'm gonna say it's 3346. Then we'll move on. 59, 22. It's probably this one right here. FS2004. Okay, so this is easy to do. 47 away. This is this is 2, 2.3, 2.3 plus this is 49.3, 49.3. This is gonna be away, but this is gonna be 4, 6.4. Okay, let's do the calculations. Alright, let's turn it back a little bit. Alright. Everything is good. Okay, let's do the calculation. So 226, 6.4 nautical miles. Two 26, 6.4 nautical miles away. .3 is 179. 49.3, that's pretty big. 179. 79. 49.3. And then 47.105. 47.105. 47.105. There we go. Okay. So this is easy to do. It's going to be 195. 195 here. And then 15. And this one is 226 minus 90. 136. 36. And then we'll have this one is 179 minus 90, 89, 89. Okay, so we are here then. It's derived 4. So actually, we need to be going back over. We need to be at 240 actually. So turn back a little bit. So we've been going south a little bit too much. Alright, so once again, this is our last star fix. This is 156 nautical miles. 56 nautical miles, 2 kilometers. 220, 218 divided by, what is it? We're at like 830 kilometers an hour now, so in about 20 minutes from now. So 1924. So we actually, again, we need to move this. Need to move this. 239. It wants us to go 238 or 40. So 239 is good. Alright, so really we want to start descending soon. I'd say in about 15 minutes we want to start descending. So let's start descending around here, top of descent here. Top of descent here is 110 nautical miles from here. Well, let's just say we've done 80 nautical miles. So, in terms of time, the next shot should be at 9:21:30, but so in actually in like 8 minutes or so, we should start descending. And that's probably going to be at around, let's see, descent here. Let's see, descent is going to be around 10 meters per second. I think this is about 2,000 feet per minute. So, yeah, 15 times 2,000 is, yeah, no. We're not going to be descending at 10 meters per second though, it's going to be like 5 because we don't have any air brakes. So, I think we should, yeah. Let's actually start plotting our next ones. Okay, so 9:30. So our this stays the same. I think 30 is like 7.31 or something like that. We gotta get this pretty accurate because we're gonna be heading to the island soon. Alright, so 5. Wow, that's actually 6, 36, 37, 237. That's pretty high. I'm just gonna ignore this. So we can do, our AP is gonna be here. 7 south, 13 west. So we'll just do 13. And it'll be 224. Latitude is 7 south. Let's go to our pub 1. Seven south. (224). 7 south, 224. So Razal Hog, Rigel, and Regulus. Okay. 45, 44. Oh, 64. 45, 44. Rigel is 3601. 3601. Regulus is 1618. And it's still 285, 182. That has changed. This has not changed even a bit. Actually, our track has changed a little bit, so we'll be a little bit careful here. 240. This this is actually where we can use the astro compass. So I'm gonna see if I can use the astro compass here. Let's see. This is a little bit cheaty, but actually let's not be cheaty. Let's try to do this properly. Okay, so we're gonna do a crux. We're gonna do okay, so the GHA is, I use the tooltip here, it says the crux GHA is 50. So 50 minus 13 is 37 LHA. So let's do that. Let's put that in here. And we're actually south latitude, so 37 LHA, south latitude, so minus 63, and then our latitude is going to be in the red, and it's going to be 6. There we go, 6 latitude south. Actually, no, sorry, I need to be here. 6 latitude south. Center these little thingies, and then we can smooth our heading. Alright, so actually our true heading is 231, so we can use that. 231 is our true heading. So we do 231. Oh no, 64 minus 231. 64 minus 231 plus 360. 193. And then, let's see. 182 minus 231 plus 360. 311. 285 minus 231. It's 54. Okay. So let's make sure we are alright, this is fine. This is perfectly fine. Okay, so let's do the motion of body corrections. Motion of body should be all the way down here. So motion of body, this is our true ZN. It's gonna be 64. 64. Latitude in degrees is gonna be, at this point it's gonna be 6, so it's gonna be somewhere between here and here. But it's gonna be plus 13.4 plus minus 13.4. This was motion of body, yes. The motion of body for this one, so 182, 182, it's going to be minus 0.5, so it's going to be plus 0.5. Yeah, plus 0.5. Motion of observer. Motion of observer, 450 ground speed. Relative ZN is 193. So we go all the way down here, 192, 193. It's going to be minus 7.3. So it's actually plus 7.3. 7.3. And then 311. So it's going to be between here and here, so that's going to be plus 4.9, so it's actually minus 4.9. Minus 4.9. Let's check the time. Okay, we got some time. Let's start descending. So, actually, let's not start descending. Let's say we're going to be at 20,000 feet. Let's say 18,000 feet. So let's start descending soon, very, very soon. Okay, minus this, sorry, this plus this, 13.4. Minus 13.4 plus 7.3 is minus 6. Minus 12.2. And then this minus 4.4. Minus 4.4 is 0. Well, fraction, I estimate we're going to be lower, so Coriolis, let's see. Coriolis, I think it actually might be, it might be 1. Coriolis correction is probably going to be 1 now. So let's do 1. So this is to the left of the track, so we'll go 1 nautical mile to the left. Let me just add a user point here, actually. Okay, let's do height above. Let's begin descending. So we're gonna start descending here. We're gonna reduce our airspeed quite a bit here. Actually, before we start descending, let's reduce our airspeed. Okay. Now, sextant height. Let's do 20. So this number is 54, 45. So it's actually going to be 1. And this one is going to be 36, so it's also going to be 1. And then this one's 16, so it's going to be 2. So minus 2 here. So this is minus 5.4. This is minus 13.2. So 13.2, 5.4, minus 2. Let's double check. Alright, so we want to be descending at around, 0.75. So we'll be descending a little bit faster than this. Okay, let's check this. So minus 7 south. Just want to double check that I've got this right. For 224 LHA. Yep, that looks all good. Okay. Damn, we only got like, much time left. 193. Shit. $193. $45.4. This is probably it right here. So 44 minus 13. 30.8. This is minus 4.6, I think. Wait. Minus 4.4, 60 minus 4.4, 55.6, 35, 55.6. And then this one is 1616. Okay. And let's do this actually. 64 plus 180, 224. 182 minus, okay, that's just 2 degrees. And then that stays the same. Okay. So we got everything set up here. I don't know why we're not descending here. Just come on, continue descending. I think our estimated time of arrival is still in about 20 minutes, 30 minutes or so. So we need to start descending though, for real. Because this is saying 9,000 meters, we want to be at 820 true. I'm not paying attention to this RPM because this is not correct. There's like no way to get that descent rate without cutting the throttle even more. Let's try to tune in the ADF is 360, or there's an NDB on the Ascension Island for 360, so we're going to tune in 360 here. I've already tuned it in over here while we wait. There's 3 minutes left. So 18,000 feet is 5,400 meters. So we need to be at 5,400 meters by the time we take this shot. So let's go down even more. Yeah. Okay. Try to get this as accurate as possible because this is our last celestial shot. Okay, we are about a minute away from our shot time. Alright, taking our shot. It's gonna be 43-38. 43-38. 38. Then we'll move on to our next one. Just averaging out 3612. And then last one. Just making sure this is the right one for sure. FS2004. Okay, let's plot this out. So this is let's make sure we're on the right course, at least 43, that's fine. We're still descending, which is good. Let's descend a little harder, actually. Okay, so this is... Jesus, 60 minus 38. 22 plus. That's 50.8. That is 52.8. That's 52.8 away. 52.8 away. And then this is towards. So this is 3. This is 60 minus 55.6. 4.4. So that's 16.4. And then this is gonna be. This is also gonna be 2. This is gonna be 60 minus 16. 44. 48. 48. Okay, so let's do this one first. 224. 224. And it's gonna be very far away. Actually, it's gonna be. Wow. So it's gonna be there. Okay, we are actually. This is probably telling of where we are, but let's see. 16. We need to be slowing down, and we need to be descending a lot more in this. Let's see. Actually, we already got something on the NDVD. Let's actually turn just a little bit. Okay, 16.4, 182, 182, 16.4, 182, 182 is 16.4. Let's do, and then 48 is 285, 48, 285, 285, 48 nautical miles. Okay, so 285 minus 90 is 195. Let's do this quickly. 195. And then from here it's 182. 182 minus 90 should be just 92, right? Yeah. So 92. Oh shit, it's actually plus. So that's still about, I think it's still 272. Okay, so we are right here. So to get to the island we need to go 228.9. So that is good. We need to follow the NDB essentially at this point. Really, we don't have much longer to go. We have 50 nautical miles, so we should be coming up there on 780. 780 divided by 60. So that's 50 nautical miles, 2 kilometers. 92 divided by 13, that's 7 minutes. Wow, okay. So actually, we may have overflown it. I'm actually not 100% sure. We may have actually overflown this thing. Let's see if we can see anything. Alright, we want to go down very, very fast now. Let's... Flight manual says we should be at 600. I think we're pretty good actually. We just need to be descending even faster, honestly. Oh, there it is. There it is. I see it. That's fucking amazing. Okay. I see the island. In fact, I see the airport. Alright, let's get our weather information for Ascension. 150 at 11 knots. So that's... yeah. We're going to be landing on this side, which is good. So let's actually let's turn out this way. Let's turn out like 300. And then we'll stay within range of the MDB and come in for a landing. Landing lights on. So we want to be at a level of 500 kilometers. We want to slow down a little bit, but yeah, see our speed. So we're at 61,000. We're actually a little bit overweight, but I think it's fine. So 61. So we need to be approaching at 250, essentially. Once we get down to 1,000 meters, I'm going to turn around, head to the NDB. And this NDB is a little bit offset too, so yeah, we're going to head this way to it. 156. Which is kind of where it's pointing anyways, but yeah. We got no DME or anything like that, so let's just keep going for a little bit. Once we get 1,500... Actually, yeah, once this radar altimeter starts working, then we're going to start making our turn. We're going to level off and make our turn here in a bit. In fact, let's just start doing that now. Let's start making our turn to the right. Oh yeah, we can actually do our meteoric system. So I think, let's see. .2. So it's, the VOR is 112.2. So we can actually do a rangefinder here. Okay, let's level out now. So we're at 1,000 meters. We're going to start leveling out here. So we're 900 meters. Come on. Let's get the nose up. Actually, they say 400 to 600 meters, so we can keep descending just a little bit because we are over the ocean. Hmm, 130 means we're probably doing like this here. We want to slow down to 400 kilometers though. Kilometers. I don't know my range yet, but okay, so we are about 20 kilometers out according to this meteoric system. The rangefinder. It's 20 kilometers out. We need to go to the right a little bit more. I don't know what's going on here. Actually, let's take manual control. Let's take manual control here. I'm going to take manual control here. Gear down. Take one set of flaps down. "15 kilometers out. Still don't see the airport. We're gonna descend. Oh, there it is. There it is. I see it. I see it. I see it. All right, there we go.
Закрылки 20, опускаются синхронно.
Descending at 300 kilometers an hour here. Let's see, I got visual with it. Okay. I see like three greens, 3 reds, I think, so let's get a little bit of speed up, a little bit less descent rate here.
Механизация выпущена.
Yeah, we need a little bit more speed here. Coming a little bit low. A little bit slow. Probably shouldn't have put out the last stated flap so early. I think that's the
Закрылки
problem.
убираются синхронно.
Alright, now we're a little bit too high.
Механизация выпущена.
Cutting the throttles just a little bit. Okay, there we go. Now on the glide path. think we're at full flaps now, so.
250 метров.
A little bit low. A little bit more power.
200 метров. Скорость мала.
A little bit low, come on. A little more speed. Yeah, a little bit too slow. Yeah, drop below the glide slope, come on.
Оценка. 80. 30.
Here we go.
20. 15. 10. Малый газ. 5, 4, 2,
Idle.
1. Посадка. Реверс приложить.
Alright. Parachute out.
240. 220. 200.
Oof. Oh, there's no parachute.
180. 160.
Jeez. That was a little
140.
bit hairy.
120.
Oh no, yeah, I did have the parachute out. Yeah.
Механизацию убрать.
Oh. Actually not sure if there's an apron here, I think that might just be it. I think this is it right here. Alright, welcome to Ascension Island.
Фары выключены, убраны. Механизация убрана.
Nice. Pretty good flight. Now we are turned off the engines, turn off all the avionics, turn off the generators. Alright, we're good. Alright. Thanks for watching.